We're going to learn about the arithmetic of matrices, including methods for how you do it, and then properties of the arithmetic too. So first, if I want to add a plus 2d, so when you add two matrices, you add component-wise, just like you add vectors, you add the like components. And when you multiply a matrix times a scalar, you multiply every entry in the matrix times the scalar. So A is 2, 1, 0, negative 3, 0, 5. And we're going to add that to 2 times the matrix D, which is 1, 1, 1, 1, 1, 1. So that's going to be 2, 1, 0, negative 3, 0, 5. Plus, you're going to multiply the matrix by the scalar, which means multiply every entry. So this becomes 2, 2, 2, 2, 2, 2. And then you add component-wise. So like entry 1, 1 adds to entry 1, 1. So you have 2 plus 2 is 4. And then entry 2, 1 adds to entry 2, 1. 1, 2. First row, second column, first row, second column. So negative 3 plus 2 is negative 1. And then 1 plus 2 is 3. 0 plus 2 is 2. 0 plus 2 is 2. And 5 plus 2 is 7. Just add component-wise. All right, if I wanted to add A plus B, 2, 1, 0, negative 3, 0, 5, plus 1, negative 1, 2, 4. Since we define matrix addition to be adding component-wise, they have to be the same dimensions, right, to be able to add them. So this is impossible. You can only add matrices that have the exact same dimensions. All right, so we've learned how to multiply a matrix times a vector. We've done that many times. We're going to learn how to multiply a matrix times a matrix now. The same rule applies for making it possible. The inner dimensions have to match. And then we're just going to expand the method that we used for a matrix times a vector. So A times B, I have 2, 1, 0, negative 3, 0, 5. And then B was 1, negative 1, 2, 4. So to make sure this is possible, I'm going to check that the inner dimensions match. So this first matrix is a 3 by 2. My second matrix is a 2 by 2. Those inner dimensions match, so I'm good. I can multiply these. The result should be a 3 by 2, the outer dimensions. So the result should be 3 rows, 2 columns. So I'm just going to put in a sort of a blank 3-row, 2-column matrix here. 3 rows, 2 columns. All right, so this is the first method. You calculate each column separately. And you use the method that we used for a matrix times a vector. So if you multiply this matrix times this first vector, 1, negative 1, using each of those entries in the vector as a weight on the columns, then you get column 1. Right? So column 1 of the answer would be 2, 1, 0 with a weight of 1 plus negative 3, 0, 5 with a weight of negative 1. And that comes out to 5, 1, negative 5. That's the first column of your answer, 5, 1, negative 5. And then you do the same calculation for column 2, where you multiply your matrix A times the second column of the matrix B. So it would be 2, 1, 0 with a weight of 2 plus negative 3, 0, 5 with a weight of 4. And that's going to come out to negative 8, 2, 20. And that's the second column of your answer. So that's using the entries of the columns of the second matrix as weights, sort of analogous to the using the weights of the vector for a matrix times a vector. Method 2 is the like pick up a row, rotate it, lay it on top. So this is analogous to that second method we learned for a matrix times a vector. So 210 times -305. Multiply that times 1, -1, 2, 4. And I know my answer is going to be a 3 by 2. So I'm going to build a large blank 3 by 2 matrix here. 3 rows, 2 columns. And I'm making it really large because I'm going to do all the work in here instead of off to the side like I did it in the other one. All right, so we fill in the blanks by multiplying each row times each column. Each row of the first matrix times each column of the second. So first, I'm going to multiply first row times the first column. And when you multiply the first row times the first column, that goes in the first row, first column of the answer matrix. And you just do the dot product. To imagine taking the 2, -3, rotate it 90, lay it on top, multiply the things that line up, and then add them together. So you're going to have 2 times 1 plus -3 times -1. Then you're going to multiply the first row of the first matrix times the second column. Maybe I'll do that in a different color. I'm going to do first row of the first matrix times the second column of the second matrix. So that's row 1, column 2. So when you take the product of those two, it goes in row 1, column 2 of the answer. So take the dot product of those things circled in blue. So you're going to have 2 times 2 plus -3 times 4. So now I've multiplied the first column times my first row. I've multiplied the first row times every column of the second matrix. So move on to the next row. So now I'm going to do second row times the first column. And that should go in the second row, first column of the answer. Right? I'm multiplying the second row times the first column, so it goes in second row, first column of the answer. So I have 1 times 1 plus 0 times -1. And I'm out of colors. Let's see, what else do I have here? Yeah, there we go. Pick a different blue. All right, so now I'm going to multiply second row, second column. 1 times 2 plus 0 times 4. So I now have done the second row times both columns, so I move to the third row. Third row times the first column. The result of that product goes in the third row, first column of the answer. So 0 times 1 plus 5 times -1. And then I have one more gray. Third row, second column, goes in the third row, second column. So I have 0 times 2 plus 5 times 4. And then just do out your calculations. So this comes out to 5, 1, -5. And that's -12 plus 4 is -8. 2, 20. So you can see you get the same answer both ways. All right, b squared. Squaring means the same thing as it does in a standard real number arithmetic. It means b times b. So we just have to do our matrix multiplication. Sorry, what was B? It was 1, -1, 2, 4 times 1, -1, 2, 4. And we could just use this as an opportunity to practice multiplying two matrices. This is 2 by 2. This is 2 by 2. The inner dimensions match, so I can multiply them. The result should be a 2 by 2. Okay, so my first entry is going to be first row times first column. So that should be 1 times 1 plus 2 times -1. So that's 1 minus 2 is -1. All right, then first row, second column. 1 times 2 plus 2 times 4 should be 10. Second row, first column, that's -1 minus 4 is -5. And one more. Second row, I already did green, oh well. -1 times 2 is -2, plus 16 is 14. All right, A transpose. So that's 2, 1, 0, -3, 0, 5. Transpose. All right, that little t means transpose, and it means take every column becomes a row, and every row becomes a column. So 2, 1, 0, instead of being my first column, is going to be my first row. 2, 1, 0. And -3, 0, 5, instead of being my second column, it becomes my second row. -3, 0, 5. And then when you do that, the rows also became columns, right? 2, -3 went from being my first row to my first column. 1, 0 was my second row. Now it's my second column. 0, 5 was the third row. Now it's my third column. So transpose just switches rows to columns, columns to rows. Okay, B times D. 1, -1, 2, 4 times D, which is 1, 1, 1, 1, 1, 1. Okay, before I start, check the dimensions. This is 2 by 2. This is 3 by 2. Inner dimensions don't match. This is impossible. C times D, that's 1, 2, 7, times D, which is 1, 1, 1, 1, 1, 1. Check the dimensions. This is 3 by 1. This is 3 by 2. Again, the inner dimensions don't match, so this is impossible. If I changed the order there, if I did D times C, still wouldn't match. So never mind. Yeah, if you did a transpose and changed the order, you could multiply them. But all right, so all we covered in the lecture portion was like the physical, how do you multiply these things. In the activities, you're going to explore some of the properties, like can you is it commutative, associative, all those things that you expect from arithmetic because it's been ingrained in you for many, many years of math education, are not all true when you're doing arithmetic with matrices and vectors. So you're going to explore that in the activities, which you can start now, or you can go back and finish what you were doing before.